Good afternoon, guys. Myself is Miranji. Okay, I am dealing the subject titled Electromagnetic Waves and Transmission Lines. This is one of the typical subject, okay, of course, in your engineering career. Electromagnetic waves and transmission lines. But according to R19 syllabus, okay, you are so lucky. Why? Because the syllabus is okay dramatically reduced to 5 units, and completely the syllabus format is quite different, okay, compared to last year's and the other university syllabuses. Okay, according to your subject title, uh, this subject contains two parts as electromagnetic waves and transmission lines. See here, as per curriculum, they mentioned what are the course objectives here. Of course, these course objectives are very slight different from okay, what we define. Okay. Okay, what are the course objectives? Actually, we define. Okay, we'll see you in the next class. But as per JNTU Kakinada, okay, the course objectives of this subject. See here, the main objective of this course is to understand what are the fundamentals of study electric and magnetic fields using various laws. Okay, and several laws are there. Okay, Coulomb's law, Gauss law, Biot-Savart's law. Okay, like that. Different laws are there. Okay, and at the end of this course, okay, we learn fundamentals of study electric and magnetic fields using various laws. Okay, that is one of the course objective, and second course objective is apply the concept of static and time varying Maxwell's equations and power flow using Poynting theorem. Okay, of course. Okay, I think you don't aware of okay all this terminology. Okay, it is quite different. Okay, different from many of your engineering subjects. Okay, but listen here. Wave characteristics in different media for normal and oblique incidence. Okay, all these are the derivations. Okay, wave characteristics in different media for normal and oblique incidence. And next course objective is implement various concepts of transmission lines and impedance measurements. See here, the course objectives are quite opposite to what are the contents they given in the syllabus. We started with the transmission lines 1, transmission lines 2, but the course objective is okay remains the same as earlier. Okay. The first three course objectives. See here. First three course objectives: fundamentals of study electric and magnetic fields, applying the concept of static and time varying Maxwell's equations, and wave characteristics. And actually, this part is called electromagnetic waves. This part is called electromagnetic waves, and this part is transmission line. And actually, this EMTL subject constitutes two parts. One part is electromagnetic waves, and second part is transmission lines. Okay, but how that electromagnetic waves and transmission lines are organized in your syllabus? Okay, actually, he started with transmission lines. Okay, that entire transmission lines part, okay, is organized as a two parts. See here, transmission lines 1 and transmission lines 2. Transmission lines 1, transmission lines 2. Okay, two parts. In transmission lines 1, they deal with types, parameters, equivalent circuits, and primary and secondary constants, and basic transmission line equations. Okay, expression for characteristic impedance, propagation constants, phase, and they are very fundamentals of the transmission lines. Okay, He is not in depth with that transmission lines part one, but transmission lines part two is the complete derivation part, and it is very, very, very important in exam point of view also. Just see here. Transmission lines 1, transmission lines 2. Okay, that is the entire transmission lines part. Okay, in transmission lines 2, see here, input impedance gradations, short circuited open circuit lines, reflection coefficient, VSWR, low loss radio frequency lines. Okay, UHF transmission lines. UHF lines as a circuit elements, impedance transformers or transformations, lambda by 4, lambda by 2, lambda by 8. Okay, and Smith chart applications. Again, how to find the input impedance of the transmission line by using Smith chart technology, Smith chart method. Okay, similarly, quarter wave transformer, that is also called an impedance inverter, single stub matching, and how to provide proper impedance match. Okay, and related problems. Okay, similarly, from unit 3, 4, 5. Unit 3, 4, 5 is the actual electromagnetic waves part. Okay, did you get it? See here, that entire electromagnetic waves. Okay, electromagnetic waves. Okay, that unit is organized as a 3 parts. See here, 3 parts as, of course, 2 parts mainly, but okay, for your clarity, I will give like this. Okay, this is the transmission line 1. This is the transmission line 1. Here, transmission line 2. And actually, this part is entirely called one part. This is the transmission lines part. And this is the electromagnetic waves part, and this is the transmission lines part. Okay, again, this electromagnetic waves part is organized as a 3 parts like this. Okay, this is the electrostatics, and this is the electromagnetics, and this is called electrostatic and magnetic combination. That is called electromagnetic waves. Okay, and this Maxwell's equations part is comes under these 2 parts. Okay. Okay, this is the tree structure, and this is the entire transmission line parts. Okay, transmission line. This is the transmission line 1, and this is the transmission line 2. Okay, these are the 5 units. Okay, these are the 5 units we are always deals with. Okay, okay, and see here, unit 3, unit 4, unit 5. What is the unit 3? Coordinate system. What is the purpose of coordinate system? Okay, we'll start freshly. Okay, don't worry about it. Review of coordinate systems. Okay, in that, first we deal with electrostatics. In that, first we have to deal with Coulomb's law. What is meant by Coulomb's law? What is the role of the Coulomb's law in point charges? Okay, and electric field density, and capital E definition, electric flux density, capital D. Okay, Gauss law and its applications. Similarly, what is meant by electric potential, and Maxwell's 2 equations for the electrostatic fields. Actually, 4 Maxwell's equations are there. Okay, Maxwell 2 equations for electrostatic fields and Maxwell 2 equations for electromagnetic fields. Okay, and what is meant by energy density. Okay, actually here capacitance okay, and illustrated problems, convection and conduction current densities, the electric constant, Poisson's and Laplace equations. See here, capacitance and the electrostatic. Okay, how the capacitor stores the energy? Capacitor stores the energy in the form of always electrostatic field. That's why here in this part it covers with capacitance, parallel plate, coaxial capacitor, and a coaxial cable. How it stores the energy. Okay, and what is the expression for capacitance of a coaxial cable? Okay, that is the unit 3. Unit 4 is the magnetostatics. Okay, or magnetostatics. Okay, previously that is the electrostatics. Here is the magnetostatics. That is the different. Okay, here also just like a Coulomb's law, here we deal with Biot-Savart's law. Okay, just like our Gauss law, here deals with Ampere circuit's law. Okay, magnet. Similarly, for electric flux density, there we see electric flux density. Here you have to deal with magnetic flux density. Okay, there we deal with Maxwell's 2 equations for electrostatic fields. Here, Maxwell's 2 equations for magnetostatic fields. Okay. Similarly, here scalar and vector potentials. Okay, forces due to the magnetic fields. Ampere force law. Okay, Ampere force law. here uh, dealt with inductance. Okay, inductor, inductance, and magnetic energy, okay, and related problems. Okay, of course, some contrast is there between the electrostatics and magnetics. And because of that static potential, static charge, it produces electrostatic field, and a moving charge produces the magnetostatics. Okay, in 3 and 4 units, okay, we dealt with Maxwell's two equations for electrostatic fields and magnetic, same Maxwell's two equations for magnetostatics, right? That combination here is given as Maxwell's equations for time varying fields. Okay, and that for static, and there is no time varying, but here is the time varying. There is a difference. That's why here the Maxwell's equations we deal with Faraday's laws and the transformer EMF, inconsistency in Ampere's law. Okay, displacement current density, Maxwell's equations in different, and I mean different forms. Okay, and a point form, integral form. Okay, several forms are there, differential form. Okay, and it word statements, conditions at boundary surfaces. Okay, that is very, very important. Okay, boundary conditions are very, very important. See here, um, last unit is the electromagnetic wave characteristics. Okay, how the wave propagated from source to destination and what are those characteristics. Okay, wave equations for conducting and perfect dielectric mediums. Uniform plane wave. Okay, relation between E and H is very, very, very important. Okay, what is the lossy medium and what is the lossless medium? Okay, how the wave propagated in good conducting medium? What is meant by skin depth? What is meant by polarization? What are the different polarization types? Okay, reflection, refraction, and plane waves. Reflection, refraction of the plane waves in normal and oblique incidences, and parallel and perpendicular. And it means okay, for both perfect conductor and perfect dielectrics. Okay, what is meant by Brewster angle? What is meant by critical angle? What is meant by total internal reflection? Okay, what is meant by surface impedance? Okay, Pointing vector and pointing theorem, and related problems. Okay, and your fundamental textbook is SADIQ. See here, Matthew NO SADIQ. Okay, that is the excellent book. Okay, all of you, please go through the textbook, Elements of Electromagnetic Waves. Okay, these are the contents available in electromagnetic waves and transmission lines. Okay. Electromagnetic waves and transmission lines. Okay, already you know how. Okay, and I want to give the introduction of that subject. Okay, and already you see what are the contents available in electromagnetic waves and transmission lines. Okay, just leave it. Okay, now okay, we go through what are the fundamentals required to deal with that electromagnetic waves and transmission lines. Okay. But as per syllabus, the first content is the transmission line. That's why I want to give the outline of the transmission lines. Okay, actually, what is meant by transmission line? Okay, most of the information available in the title itself, right? Here, transmission lines. Transmission line. Transmission line. Transmission line is the physical medium. Transmission line is the physical medium. Transmission. What is meant by transmission? Transmission lines. And the lines which are used to transfer. Okay, the lines which are used to transfer. But what we want to transfer? What we want to transfer? What we want to transfer? Through that lines. Okay. Already you best aware of. Okay, or that well known is the power transmission lines. Okay, what is the purpose of the power transmission lines? Okay, what they convey? Okay, that the power lines always convey power from one location to another location, right? One location to another location. Okay, and that power lines are the physical medium. The power lines are the physical medium. Okay, that physical rails. Rails means lines. Okay, that is rails. Okay, are physically available between the nodes, right? Nodes means current poles. Okay, current poles. Okay, current pole to pole is connected with one, okay, physical connecting wire. Okay, that physical connecting wire is a transmission line. Okay, that power lines are used to convey or transmit power. Okay, but here, okay, as a part of electronics, as a part of the electronics, or as the electronics engineer, as electronics engineer, not electrical, as the electronics engineer, here transmission lines are always dealt with the physical lines which are used to convey our voice signals. What? These are the lines which are used to convey our voice signals. That's why here we always deals with not a power. Okay, of course, power, but it's very low. Okay, and energy transfer. Okay, that energy transfer in the sense. Okay, just I am speaking here and within the college only. Okay, in front of me one headset is there. Okay, in that headset one mic is there. That mic is converting my voice signal into equivalent electrical signal. Okay, the electrical signal is passed through the remaining cable of this headset and going to, or the transferred into laptop. Okay, in that laptop one modulation technique is preferred. After that modulation, again it is retransferred to you, right? Okay, and you are listening my voice, but how it is possible? Okay, without mic. Okay, without the physical connection between that mic and laptop. Okay, and this is the one transmission line. Okay, and from that laptop, okay, it is again going to broadcast, okay, to entire the students, okay, to all the students. Okay, that is again wireless, right? Okay, or okay, and actually that Wi-Fi is connected to my laptop. Okay, again that signal is re-radiated into space. Okay, again that's why here transmission lines and electromagnetic waves and wired and wireless communications are suitable. Get it? Here transmission line is always the physical medium exists between source and destination. I am the source and you are the destination. Okay, and you and me are connected with one physical medium. No. Okay, here mediums are different. Here medium is the always mixed form. Okay, some part is wired and some part is wireless. Okay, that's why electromagnetic waves and transmission lines, okay, came into the existence of a single subject. Remember that point. See here. Transmission lines one. Uh, this transmission lines one always gives the fundamentals of transmission lines. See here, types. What is meant by types here? And what are the different types of transmission lines existed? Okay, what are the different types of transmission lines existed? Okay, in practical, what we see and which type of transmission lines are existed. Okay. See here, our headset having this is our headset having uh, some carrying connectors inside, right? How many carrying connectors are there? in your headset, two, okay, two headsets, I mean, two conducting wires are there, okay, one positive and one negative, right? Okay, that is called two wire or parallel wire transmission line. What they are called? Parallel wire transmission line. Okay, at the same time, ribbon type is also there, ribbon shape, just like, of course, it contains two wires, two conducting wires, either copper or aluminum, but they are that, okay, that cable is very stiff and available like a ribbon. That's why that is called a ribbon wire. Ribbon wire is the another transmission line. Okay, and another transmission line is, uh, see here, I mean, your fan or your light, tube light, or uh, some incandescent lamp. Okay, all those doors are always connected with one black and red connecting wires. Yes or no? Black and red. Okay, and that black and red connecting wires are always twisted each other. Okay, twisted. Okay, that is also one type of transmission line. Okay, and such type of model is used for conveying wire signals. Okay, that's why that is also twisted wire transmission line. Twisted wire transmission line. Okay, okay, I will see. Okay, in the next class, we will clearly show uh, what exactly it is. Okay, in PPT. And another type of transmission line is coaxial cable. Coaxial cable. Coaxial cable already you know. Okay, even our TVs are always connected with coaxial cable. Okay, observe your TV backside. Okay, your TV backside is always connected with one coaxial cable. The coaxial cable is having inner conductor and outer conductor, and inner insulator and outer insulator. Inner conductor is protected with inner insulator. Okay, on that inner insulator, one silver type, okay, ground terminal is there. Okay, it is look like a mesh. Okay, on that we are having one thick black insulator. Okay, that is a coaxial cable. That coaxial cable is also one of the transmission line. And these are the different different types of transmission lines. They are physically available. They are physically touchable. That is the transmission lines. See here types of transmission lines. Okay, now we discuss it. Next, what are the different types of parameters? What are the different parameters of the transmission lines? Okay, what may be what parameters it may contain? What parameters the transmission lines may contain? Transmission line is always convey information from one place to another place, right? Transmission line basically a physical medium that conveys information from one place to another place. Okay, but is it exactly convey the same potential or same energy from source to destination? Is it possible? No. Okay, it is not possible. Why? Because the transmission line is a physical medium. That physical medium always offers some resistance, right? Here, that resistance is called an attenuation. Okay, and it decreases signal strength while increasing its length, right? And the wire itself offers, okay, the wire length or wire thickness or wire cross sectional area itself offers some resistance, okay, some capacitance, some conductance, some inductance, okay. Right, wire itself offers some parameters like wire resistance, capacitance, inductance, and conductance. That's why the parameters of that transmission line is classified into two types. Okay, how many types? The parameters of the transmission line is classified into two types. What are they? They are, first one, primary constants. What? Primary constants. And what are the prime important factors of transmission line? What are the prime important parameters? Okay, whenever the length of the transmission line or length of the wire increases, is it the signal strength remains constant? No. When the length of the wire increases, okay, length of the wire increases, signal strength decreases. But how the signal strength decreases when length of the wire increases? When the length of the wire increases, the resistance offered. Why? Because it is not a superconductor. Okay, it is just conductor. Superconductors means gold and silver. Okay, but when we prefer the gold and silver or a transmission lines or physical medium, okay, in the public environment, okay, is it okay, is it the public uh, maintain that gold and silver in publicly? No. Okay, why? Because the gold and silver materials are very costly and very expensive. Okay, that's why. um and because of that, okay, and human mentality, that gold and silver materials are not preferred as a physical transmission lines in public. Yeah, of course, that gold and silver is used in our laptops. Okay, uh, and for as a alloys, right? As a alloys, microwave devices. At a microwave devices, the gold and silver terminals are preferred or they used. Okay, why? Because they are able to generate very few microvolts. Okay, few microvolts to millivolts. That's why, and for the purpose of saving, they here we always use gold and silver combined materials as a terminals. But in practical, we always use copper, aluminum. Okay, such type of materials are used in transmission line, but its resistivity is somewhat poor compared to gold and silver resistivity. Okay, that's why the resistivity is very poor. Resistivity is poor in gold and silver, and resistivity is high in remaining materials. And whenever the length of the wire increases, the resistance also increases. Okay, at a length, resistance always varies with respect to length. Of course, that resistance or capacitance or inductance or conductance available in that wire is not physically touchable. Okay, that R, G, C, L. Okay, resistance, capacitance, inductance, and conductance. Okay, those parameters are called primary constants. Resistance, conductance, inductance, and capacitance. Or LGC are called primary constants. Okay, that is very, very, very important in transmission lines one. Okay, parameters. Similarly, secondary constants are also there. But what is the difference between the primary constant and secondary constant? Primary constant and secondary constant. Primary constant and secondary constant. Primary constant parameters are always RLGC, resistance, capacitance, inductance, and conductance, whereas secondary constants are always constitutes with primary constants. What it means? That secondary constants are always built up with primary constants alone. Okay. But is there any classification in secondary constants? Of course, primary constants means RLGC. Okay, four parameters are there. But secondary constants, okay, formed with primary constants. Secondary constants are formed with secondary constants or formed with primary constants or LGC. Okay, here the secondary constants are propagation constant gamma, characteristic impedance Z naught. What are they? Secondary constants, or first one propagation constant gamma, and second one characteristic impedance Z naught. Okay, gamma and Z naught. Gamma and Z naught are the secondary constants, where gamma is represented with square root of r plus j omega l into g plus j omega c. R plus j omega l into g plus j omega c. Okay. Okay, I am not saying here, but in tomorrow's class, okay, I will clearly mention with PPT. Okay, just listen what is what here. What is the prime constant of secondary? Not a primary constant, secondary constants. No, primary is the propagation constant. The propagation constant is always represented with, okay, that always represented with gamma. Gamma equal to square root of what? R plus j omega l, gamma equal to square root of r plus j omega l into, okay, r plus j omega l into g plus j omega c. R plus j omega l into square root of, okay, r plus j omega l into g plus j omega c is the primary constant mean. Okay, prime secondary constant. Okay, another parameter is the Z naught. Z naught means this is the Z naught. Okay, this is the Z naught. Okay, there is no gamma here. R plus j omega l by, see here divided by r plus j omega l by g plus j omega c is the characteristic impedance. That is the difference. Okay, propagation constant and characteristic impedance. Propagation constant and characteristic impedance. Propagation constant is square root of r plus j omega l into g plus j omega c, whereas Z naught equal to square root of r plus j omega l by g plus j omega c. Okay, that is the difference. Okay, and next one, T and phi equivalent circuits. Okay, I will show you in the next class. Okay, just it's very simple. That is the equivalent circuit of RLGC, right? This is the R, this is the L. Okay, this is the G, and this is the C. See here, RLGC, RLGC, RLGC. See here, and when we consider that GC on both sides, it looks like a phi shape. That's why that is called a phi. Okay. Okay. Otherwise, just remove the both sides here. Okay. Or consider R arm. Okay, same RL on the both sides. See here, it looks like a T shape. From that, here they classified uh, that transmission line equivalent circuit as T type and phi type parameters. Okay, or T type and phi type equivalent circuits. Okay, transmission line equations. What are the different transmission line equations? Okay, two transmission line equations are there. Okay, I will tell you in the next class. Primary and secondary constants. Already I told you what is meant by primary and what is meant by secondary constants. Primary constants are R, L, G, C. R, L, G, C. Resistance, inductance, capacitance, and conductance. Capital R is the resistance, L is the inductance, G is the conductance, C is the capacitance. R, L, G, C are the primary constants, and gamma and Z naught. Gamma and Z naught are the secondary constants. And expression for characteristic impedance. Already I told you what is the expression for characteristic impedance Z naught. Z naught equal to square root of R plus J omega L by G plus J omega C is the expression for characteristic impedance. Propagation constant expression. Okay, the constant propagation constant expression is square root of R plus J omega L into G plus J omega C. R plus J omega L, R plus J omega L into G plus J omega C is the propagation constant. Phase and group velocity. Phase and group velocity. Phase and group velocity. Phase velocity is represented with V sub x p. Phase velocity. Group velocity is represented with V sub x g. Okay, and I mean phase velocity V sub x p equal to square root of omega by beta. Okay, a small derivation is there. Okay, in the derivation part, we will clearly discuss about the phase velocity. Similarly, group velocity also same. Okay, but the difference between the phase velocity and group velocity is the change. Okay, differential d omega by d beta is the group velocity. Infinite line, lossless line. Okay, lossy line and distortionless line. Okay, and several conditions are there. Okay, and when the line is said to be lossless, okay, when that line is said to be uh, distortionless, okay, when the line is said to be infinite line, okay, several illustrations are there and related problems. Okay, that is the transmission lines part one. See here the transmission lines part two. What is the input impedance of the transmission line with short circuit and open circuit lines, and reflection coefficient of VSW, reflection coefficient. Okay, the reflection coefficient is represented with cap K, small k, VSW or voltage standing ratio, low loss radio frequency lines, and UHF transmission lines. Okay, different line, lossless line, distortionless line. Okay, some distortionless condition is also there, and the line is said to be distortionless. If the line is said to be distortionless, it has to be maintain some condition, that is R by L equal to G by C, R by L equal to G by C, or simply LG equal to RC. Okay, simply LG equal to RC. You can remember that point. That is a distortionless line. Okay, similarly lossless line. Okay, and when the line is said to be lossless, okay, when the line is said to be lossless, only if and only if the line is said to be lossless. Okay, uh, the line is said to be lossless, where the loss parameters, just like that resistance and conductance, must be zero. That is R equal to G equal to 0. When R equal to G equal to 0, the medium is said to be lossless. Okay, not a distortionless, that is a lossless. Okay, what is the input impedance relations? Okay, for the transmission line, what are the different short circuit and open circuit lines? What is the reflection coefficient? Okay, okay, all these parameters we'll discuss in later classes. Okay, that's all about today's class. We will continue in the next class. Thank you, everybody. నేను ఓన్లీ సిలబస్ మాత్రమే చూపిస్తున్నాను మీకు.